I have finally fixed my virtual machine and it no longer has the timing issue. However, the initial recording of this video, I went down a bunch of debugging rabbit holes and landed on a hacky workaround solution that actually didn't fix the problem. But I'm going to include that recording because I think it's kind of neat to show the failure part. But I will show you what I eventually figured out and eventually fixed at the end of the video. And hopefully I'll have a timestamp in the description so you can skip ahead if you don't want to watch the slow part. Although I think the slow part is interesting and highlights a lot of really good comments from viewers. Anyway, we'll jump into the original recording now. Hello and welcome to the update video on my virtual machine weirdness. We got a lot to cover. Basically, I upload this video. I will link in the description. But a lot of you commented and a bunch of ideas here. And spoilers, I've already gone through them all and I've already tried all the things. There is a workaround that I have found so far, but it is imperfect. Actually, I have several workarounds. But let's just jump into the various comments and go through some of the things that you suggested and things that worked and didn't work. So we're gonna start with this one. Try it, but not Python. I had a bunch of you tell me, oh, it's Python bad. And I had actually already tried this in C. I wrote a small little C program here, basically using clock get time, calling the monotonic clock directly, and doing essentially the same as what the Python script was doing, calling Python with nothing in the middle, waiting for that to exit, and then grabbing the time again. And if we compile this, and sometimes when you run it, it gives a non-zero number of nanoseconds, but if we replace 8 out, we run it enough times, sometimes you'll get 0 back. And so this is sort of exactly the same behavior that we're seeing in Python, but now you can kind of see a distribution of timings here. Sometimes the timings are almost exactly the same amount apart, which is a little suspicious. But anyway, I did try in C. It's not Python. Okay, cool. On to the next comment. Nikita proposes, I wonder if a different VM technology on the same machine experiences these same issues, etc., etc. I don't really want to switch away from VirtualBox. I didn't actually try this one. Docker isn't actually a virtualization technology, but that's me being pedantic. Didn't really want to try anything other than VirtualBox, and I know it works in VirtualBox on other machines, so it might be a bug in VirtualBox, but I'm not really going to explore the other ones. I also know that WSL breaks VirtualBox in other ways, and I already have everything set up here, so I wasn't really going to explore that, but it's a good suggestion nonetheless. Next one, does it happen on a newly created virtual machine? Yes. So there was kind of the idea that maybe because I built the virtual machine on a different platform and copied it over here, that there was some processor specific stuff baked into this VM. There's no such thing like that. No, to the VM, it basically just looks like a x86 64 processor, and there isn't any specific bits there. But I did try it on a fresh VM just to make sure and put this comment to rest. So it wasn't that either. Next person asked what version of AGESA it was running, and this is the firmware, the microcode for the processor, motherboard, etc. Basically, the drivers for the processor. Not exactly the same, but similar in idea. And I commented that I had updated them when I built the machine, so this was like a couple of months ago, and so I didn't really think this was going to fix the problem by updating them again, but I did update them again, and it made no difference. So yeah, they are updated often, but this processor is over a year old, so I doubt they're providing targeted fixes for it. So I did upgrade my processor firmware. Didn't make a difference there. Next, if the host is Linux based, it's not. I'm actually on Windows. There's all my debugging and driver stuff from before. I'm actually on Windows, but they suggested trying on bare metal, and so I made a live USB of Ubuntu, and I booted into that. And actually, the crazy thing, I think this is completely unrelated to my problem here. The crazy thing is every time I tried to boot into the live USB, it crashed the Ubuntu installer. And I think that's not actually due to this timing issue. I think it's due to I have too many large monitors and the Ubuntu installer doesn't come with NVIDIA drivers. And so I think it was just crashing due to graphics problems. I was able to boot into it in graphical safe mode or whatever they call it in the Ubuntu installer. And I was able to get a working terminal and try out exactly the same thing here. I didn't try the C version, I tried the Python version. And it worked fine on a live USB. So that sort of confirms my suspicion that it has something to do with the virtualization layer and some probably bug in VirtualBox or other things like that. So it does work on the host. It also works on the Windows host, so there isn't the timing issue there. But it works fine when I boot directly into Linux. Hello, boot it from a live USB. Next comment, and this is actually where this comment and the replies here is actually where I found something that pointed at a difference here, which I find really interesting. Particularly Pythonic says, does your virtualization software allow the guest OS to use hardware performance counters? If not, that might be a factor in this. My understanding is that it does, and actually the comments by the other replies here helped me figure out more of what's going on here. The first thing is they recommended checking the clock source and the paravirtualization background. They eventually told me a little bit more details about how to get the clock source down here. And I have that command in Control-R. And you can see that the current clock source is KVM clock. And this is the difference. This is one difference between this virtual machine and the identical virtual machine on a different computer. On the other computer, it reports TSC as the clock source. And from some reading, TSC is the most performant and most reliable clock source for modern processors. I mean, not even modern processors. Like everything since the Pentium has supported TSC, and it tends to be the fastest way to get a clock value and the most reliable. And so the fact that I have KVM clock here points at a problem here. They also mentioned, maybe it wasn't this commenter, but there was another commenter that recommended checking dmessage to look at mentions of clock source. And if we do sudo dmessage and then grep-i clock, type in my bad password, we get a lot of stuff here, including including a kernel panic, but I think this is just VirtualBox nonsense stuff and not related to our actual problem here. We get a bunch of stuff here. So blah blah blah, KVM clock. It's the part where it mentions TSC in here. Yeah, here we go. So TSC is what we expect to get, but we don't get it properly. And actually, we get a few interesting messages about TSC here, including firmware bug. TSC doesn't count with P0 frequency. P0, I think, being the 0th processor. So something a little bit strange going on here. And additionally, we actually get the TSC clock source disabled. And this is because the kernel, when you're booting, checks each of the clock sources and makes sure that they're accurate. The way it checks TSC, or one of the ways that it checks TSC, is by comparing the TSC values on the first two CPUs. And when it did this, it noticed a drift of 101,431 cycles, and let's see, about 4 gigahertz. So let's see, go to Wolfram Alpha, 4 gigahertz. This divided by 4 gigahertz should give us an amount of time, right? Oh, I need to put this in parentheses, of course, and zoom it in so that the video can see, which is about 25 microseconds, which I did some research on this particular processor, and this amount of drift between cores is much, much higher than the actual cores have in drift. Like, I downloaded some other software that allowed you to actually kind of compare the clock values against every single core in your CPU, and makes this pretty triangle, color coded and such. When I did that, the clock skew between the various cores was on the order of nanoseconds. It was like tens of nanoseconds. So this is some much larger value than I'm seeing here. And so like this is why the kernel turns off TSCs, due to this clock warp here, or this cycle warp here. So we've sort of identified one, like we have a clock source, KVM clock, that's unreliable, and we know why TSC has been disabled. TSC is the clock source that we want. And so this explains why the problem is happening. And so this comment was instrumental in figuring out, oh, that one. No, this one. This comment was instrumental in figuring out sort of what's going on here, and like how to explain what the problem is. It doesn't help us fix the bug, but it does give us an idea of what's going on there. This same comment also recommends adjusting the paravirtualization setting. I actually have this set to the default, and settings, advanced, no, where is it? Processor, acceleration. Yeah, paravirtualization interface default, and the default for Linux guests is KVM, which is, I guess, where we're getting that KVM clock from, current clock source. If you look at available clock sources, there are only 2 available. Normally you'll see TSC is the first one here on a healthy system. Another comment, which I haven't opened up in a tab here, recommended disabling paravirtualization just to see if it fixes the problem. And it turns out it does, but it only does that by disabling, well, fixes the problem. It disables KVM clock, and so it falls back to this ACPI PM clock source. From a little bit of research, this clock source has fairly low resolution and high performance overhead, and so this was it was able to allow me to profile things, but the system stability and performance took a hit because of using it. And so disabling paravirtualization also fixes the problem, but not in a way that was reliable enough to actually get working here. This commenter also recommended forcing TSC. And it turns out that this command does nothing when TSC is not in the available clock sources. But I'll show you how I actually forced TSC and sort of fixed the problem. I mean, dmessage is telling me that I shouldn't enable TSC due to both of these things. But if I force enable it, it does actually fix the problem, and it seems to make my VM software a lot more stable. While testing all of these things, I was rebooting the machine over and over and over, and some of the things that I tried were really unstable. Like disabling paravirtualization made my boot success go from like 90% of boots were successful to like 20% of boots being successful. And in fact, I was trying to record trying all of these things live, and I found that I was just sitting there for like 20 minutes waiting for it to boot and reboot, and footage was terrible. So we're going with this summarization format instead. And the last thing that I wanted that I guess not really a YouTube comment, but this was from Twitter, from Pablo, who is one of the CPython maintainers, core devs, if you will, recommended trying the virtual machine with just a single CPU. And it turns out if I force this virtual machine to have exactly one CPU, it uses TSC because well, I guess the main reason is it doesn't attempt this TSC synchronization at all. There's only one core, so nothing to synchronize against. And so it did enable TSC, and when TSC was enabled, my timing script worked fine. However, dropping the machine down to one core made it really unstable. It took me like 20 reboots to get the machine to even start. Once it started, it was very slow and had all sorts of other problems. So those are all the things that I tried, all the things that you recommended. And I still don't have a complete solution, but I do have a hacky workaround. And that is to force TSC to be enabled by setting a boot parameter, TSC equals reliable. This will say, to hell with your validation on this timer, just use it anyway. I don't think this is recommended, but when I set that particular boot parameter here and reboot now, setting that boot parameter allows me to get a working timer and virtual machine. Now, if I'm understanding the error messages correctly, there is a little bit of risk in enabling this setting here. Notably, if I perform a timing measurement on one core and then switch to another core and perform a timing measurement there, due to that 25 microsecond skew, there's significant potential of getting a negative value or getting a value that's nonsense. And so it's not actually fixing the problem, but more or less just working around the problem. The cool thing about TSC, or when I forced it to be enabled, oh, we are going to get a bit nice. When I forced it to be enabled, all of the problems that I'm seeing, or that I was seeing in the original video, you know, the surprising 0 nanosecond timing, the network being disconnected, and the dead terminal tabs, all of those seemingly went away. And password, oh nice, we didn't even have to wait. All of those problems seemingly went away, and just quickly get this zoomed in for the YouTubes. And if we try our best of, you'll see that we have non-zero time again. So this has sort of fixed the problem for me, or at least fixed it enough that I can feel less frustrated using my virtual machine. And if we, let's see, available clock sources again, you can see now that TSC is among our available clock sources. And if we look at the current one, we get TSC, which is great. And now it matches my other machines. Okay, so ignoring all of that, here is how I actually fixed the problem here. And first I wanted to just show you that it's fixed. So if we do our best of here, you can see that we get non-zero time, thank goodness. If we look at our available clock sources and look at the first one, we have to do this to say current, although I think they're in priority order because they're not alphabetized. It's using the right clock source, great, awesome. I also want to show that I don't have TSC equals reliable here, so it is just, it is detecting valid TSC without any special hack or override to force it there. And so things are working. Things are working. Amazing. How did I get here? So after doing the other recording and spending a couple more hours debugging the problem, because I wasn't really satisfied with my hacky workaround, I knew there was something up that was not quite right. I decided to dig into the VirtualBox log. And this is conveniently named vbox.broken.log. And I searched, or I scrolled through this and I found this thing here, which it turns out I have actually seen this particular log line before, so I actually know what the problem is here. I don't know why I didn't think of this earlier, but fortunately I was scrolling this log and saw this. Attempting fallback to NEM, AMDV is not available. Well, actually, I haven't seen exactly this log line. Instead of AMDV, I saw the Intel version of this, which I don't remember what it's called. But what this log line means is that Hyper-V is running. Hyper-V is Windows virtualization hypervisor framework thing. And generally, for the longest time, it was completely incompatible with VirtualBox. And VirtualBox has some like compatibility layer to sort of make it work with Hyper-V, although it's pretty buggy and is actually the cause of all of the bugs that in fact, like even VirtualBox is like, yeah, so this might work. We're gonna try Hyper-V. We'll see what happens here. And yeah, it explains all of the buggy behavior I was seeing. You know, like unreliable booting, weird clock nonsense, network disconnects, graphical glitches, you name it. All of those are sort of explained by Hyper-V. And didn't even think to check for Hyper-V because on my previous machines, it was disabled by default. However, this machine is Windows 11, and so Windows 11 has a whole bunch of new things based on Hyper-V, and so it was turned on by default. And so I did a whole bunch of things to disable it, including like turning off a bunch of Windows features. I had to modify a boot parameter. I had to restart my machine, my whole machine, not just the virtual machine, my whole computer, like 5 or 6 times. You also, I also had to pull out the power cable because it turns out in modern Windows, shutdown actually doesn't completely shut down. It puts it into like an extremely low power state and stores some running processes to like make boot faster or whatever. So pulling out the power actually shuts it down, and so that was how I had to actually change the boot parameter. But anyway, managed to finally disable Hyper-V, and this is now no longer present in the VirtualBox startup log, and is now using AMD-V directly, which is sort of VirtualBox's native mode. Much less buggy implementation than the Hyper-V compatibility layer. And it all works now. So I can rest easily. I can sleep now. Anyway, I'm glad I finally got to the bottom of this. I hope you found this interesting, as well as my debugging journey and all of the things that I learned along the way. And thank you so much for all the comments. They definitely helped me